Good afternoon, everybody. You are welcome to my YouTube channel. Today, we are taking the part two of the laws of indices. In the part one, we have seen 7 laws of indices, and we have seen how we can apply the first 4 laws of indices. In today's video, I hope you still remember the laws of indices, and we are going to be applying the last 3 laws of indices, solving more difficult questions. Now, let's start by seeing how we can apply that in solving these questions on the board here. First, if you're asked to solve, simplify the following: a 16 raised to power 1 all over 2. Now, always remember that any fractional index, fractional power, it invites our square roots. So you must always have a root anytime you have a fractional power. Now, it now depends what the fractional power is. Is it a unit or is a number greater than 1? If it's 1 that is the numerator, you not have a power. But if it's a number greater than 1, that particular number that is the numerator in the fraction will now become our power. While the denominator is the number of square roots that we will take. Now, let's look at this here. So what I'm saying is this: if you're having 16 raised to power 1 all over 2, because of this fraction, we are going to be having square root of 16. The denominator here is 2, so we are taking the square root. So this sign alone shows that is a square root, so no need of putting 2 there. So since the numerator here is 1, there's no need of putting raised to power 1. So what we are going to solve is this. So what is the square root of 16? Square root of 16, what can we multiply 2 times? That will give us 16. It's 4 times 4, 16. So we are having square root of 16 to be equals to plus or minus 4. Plus or minus 4. Now that is how to do that. Now let's go to the B. 27 raised to power minus 2 all over 3. Yes, the same way we do that, that's how we are going to be doing this too. But remember, it's having a negative power. So, and we know that anytime we're having a negative power or a negative index, that negative gives us an inverse sign. So we are going to be taking the inverse of that particular base, which is 27. So we'll be having 1 all over 27 raised to power 2 all over 3. So the negative is no longer in the denominator. The negative has changed to the inverse of that particular base that is carrying the power. So here now, we'll be having 1 all over, since this is a fraction here, our square root will come in, then the denominator is the root. We are taking the cube root of 27. Our numerator is 2, is no longer 1 this time, 2. So that's what we want to simplify now. If we simplify this, we'll be having cube root of 27 means what can we multiply 3 times? A particular number 3 times that will give us 27. If we try 2 times 2, 4 times 2, 8, it's not giving us 27. But if we try 3 times 3, 9, 9 times 3, 27. So that shows that our cube root of 27 is what? 3. But remember, there's a raised to power 2 after you look for the cube root of 27. So we are going to be having 3 raised to power 2. And 3 raised to power 2 is 3 times 3. That gives us 9, our final answer. Now let's look at the number C. The C part says that we should simplify 4s squared all over 9 raised to power minus 1 all over 2. Now, if we want to simplify this, because it's having a negative power there, first thing is to remove our negative by having 1 all over 4x raised to power 2 all over 9, everything raised to power 1 all over 2. So here now, it means we are dividing 1 divided by 4s squared all over 9 raised to power half. This gives us division, we always change to multiplication. then you reverse the fraction after it. So we'll be having 1 times 9 all over 4s squared raised to power half. So from here, this will give us 1 times 9, we're having 9 all over 4s squared raised to power half. Now, what this shows is that anytime you are taking the inverse of a fraction, what you do here, when you take the inverse of a fraction, is just to reverse the fraction. Instead of 4x all over 9, you change it to 9 all over 4x. Then you can easily solve. Now, if you have to solve this denominator means square root of 9 all over 4x squared. So you take the square root of 9 all over, take the square root of 4s squared. Square root of 9 gives us 3 all over square root of each of them inside the square root. Square root of 4 is 2. Square root of s squared is x. That's our final answer. Now, the D part now. The D part says we should simplify 8y raised to power 3 all over 27p raised to power 6. Everything raised to power minus 1 all over 3. So we apply the same method here. Because of the negative inverse, it becomes, let's apply that short form that I told you before. Anytime you're having a negative inverse, we'll reverse the fraction. So if we reverse the fraction, this will give us equals to 27p6 all over 8y3. Everything raised to power 1 all over 3. Now from here, you can easily simplify. This 3 here means the cube root of everything that is carrying the 1 over 3. So in this case, we are going to be having cube root of 27p6 all over 8y3. So each of them inside the cube root, what can we multiply 3 times that will give us each of them? So here we are having 27 is 3. P raised to power 6 is P raised to power 2. P raised to power 2. Then the denominator 8. What can we multiply 3 times that will give us 8 is 2. Y raised to power 3. What can we multiply 3 times that will give us y raised to power 3 is y. Y times y times y gives us y. So simplifying that gives us this final answer. There's another method you can use for this. Let me just explain the alternative method here. Alternative method for the D. So this D you can solve as this. So after you have actually taken the inverse of the fraction because of the negative, we're having 27p6 over 8y3 raised to power 1 all over 3. The negative is gone because we have taken the inverse. So here now, we'll be having, because it's cube roots that we want to take. So what you do here is to raise everything inside the bracket, raise it to power 3. So here, 27 is 3 raised to power 3. P raised to power 6. We're having P raised to power 2. Times 3. So here we're having 2 raised to power 3. Then here we'll be having y raised to power 3. Now, because everything is raised to power 3 now, we are just going to pick each of what is raised to power 3. So here now, we are going to be having 3, P2 raised to power 3, P2 all over 2 raised to power 3, 2, it gives us the same answer like we got in the first one. So this is how you apply the laws of indices to difficult questions like this. If you have questions or if you needed further explanation on this, feel free, comment in my comment section, like and subscribe to this channel if you've not done so. I'll see you in my next video. Have a wonderful day. Thank you.